All right, hi Bio. I thought I would make a quick screencast on sex-linked problems. So I'll do two examples basically to kind of illustrate how we do these. So hemophilia and colorblindness are two conditions in humans that are sex-linked and they are recessive. With humans, basically, unless we're otherwise told, we will assume that they are X-linked, meaning they travel on the X chromosome and not on the Y chromosome. So sex-linked basically means it's on one chromosome or the other. In terms of sex chromosomes, usually we'll assume that it will be an X-linked condition unless we're told otherwise. So the first scenario that we have is a man without hemophilia marries a woman whose father had hemophilia. What's the probability that they'll have a son with hemophilia, they'll have a child with hemophilia, and then the third one says that their first daughter will have hemophilia. So the first thing we need to do is talk about how we notate these. So we know that males are XY and females are XX. Then, kind of like blood type, we use sort of like looks like an exponent, lettering system to note, in the case of hemophilia, this would be an X chromosome with the normal hemophilia, like they don't have hemophilia basically, and then a lowercase h to indicate that this X chromosome does have the allele for hemophilia on it. And so in this problem, we have a man without hemophilia, which tells us that his genotype we know is XY, and then since he doesn't have hemophilia, we would say that he has that dominant H. And then a woman whose father had hemophilia, I should put that she is a normal. So she doesn't have hemophilia either, but her father did. And so this tells us that if she is XX, she doesn't have hemophilia, so she must have an X big H. But since her father had hemophilia, the only allele that he could give on the the only X chromosome he could give carried the hemophilia allele on it. So that is her genotype. So then we will make ourselves a Punnett square of these to help us answer our problems. And so the first one says, okay, that they will have a son with hemophilia. So that says, okay, basically they aren't specifying that they already have a son or that it will be their first son. So we'll just say, okay, what's the probability that they would have a son with hemophilia? So the genotype we're looking for here is XhY. And when we look at our Punnett square, we say that's a 1/4 chance. The next one says, what's the probability that they'll have a child with hemophilia? So we don't care about the biological sex here. We're just looking for anyone who has who would have the hemophilia condition. So these would be the two genotypes that we are looking for. There's only one that shows up in our Punnett square. So the answer here would be 1/4. And then the next one is that their first daughter will have hemophilia. So this first daughter part tells us to focus on only the Punnett squares that have daughters in it. And so that their first daughter would have hemophilia, we would be looking for this genotype, that XhH. That doesn't show up at all in our Punnett square, so we would say that the probability would be 0. Okay, so that's kind of how we work through these problems, how we figure out the genotypes of the parents, and how we can then use that to answer these questions. Knowing that our questions are kind of nuanced, so we need to be really careful with the language that we are looking at when we're answering the questions. I encourage you to do the second one now that I've done the first example on your own. So pause the video, try it, and then click resume. I'll get started though. So a woman whose father was colorblind marries a colorblind man. I should say again here, we're gonna go with she's like phenotypically normal. So she doesn't have colorblindness, but because her father, so we're gonna use a similar notation system. I tend to put little like dashes over the lowercase letters of letters that look the same. So this X chromosome with the big C is telling us a normal allele is on the X chromosome, where the X chromosome with the little c is telling us that the colorblind allele is on there. Okay, and so when we're talking about the genotypes of our parents, we have a woman who's normal, so that means she has at least one dominant allele. But since her father was colorblind, this tells us that he gave her a recessive allele, and then she's marrying a colorblind man, so we know that he is XY. And since he's colorblind, we know that his only X chromosome carries the recessive colorblind allele. So then let's make ourselves our Punnett square. Okay, and so the first one says the probability of having a colorblind child. So with that one, we're looking for the genotypes X little c, or X little c y, so colorblind male or colorblind female. And we would see that that happens in 1/2 of our Punnett squares. So that's a 1/2 probability of having a normal daughter. So this doesn't tell us like that we have a daughter and what's the probability that she does not have color blindness. It's just saying what's the probability of having a normal daughter. So we're looking for this genotype. It doesn't matter as long as she has a double or at least one dominant allele. We're looking for these genotypes in our Punnett square, and we will say that that happens 1/4 of the time. If the question had been changed to that their daughter would not have color blindness or would be normal, then that answer would change to 1/2. And so if you have questions on why that is, please let me know. And then finally, a colorblind son. Again, it doesn't tell us that their first son will be colorblind. It's just saying that they have a son who's colorblind. So it's basically asking us to look at the whole Punnett square and how often does this genotype show up, and that would be 1/4 again as well. All right, well, I hope that was helpful in kind of how we go about identifying genotypes, using our notation system for X-linked conditions, and then how we kind of try and look at the nuance of language to make sure that we're giving the correct probabilities when we're being asked that. All right, see you in class.